In this video, I'm going to show you how to construct a simple decision model. We're looking at a lock and a dam. Here is the lock that allows vessels to move from one side of the dam to the other. Now, I would like you to imagine that we have a choice to make. Suppose the vessels coming through this lock have to wait a long time, and time is money and it's costly for them. One option might be to construct a new chamber here. Maybe we could make a chamber that was wider and something or bigger that would accommodate a larger tow all at once. Or we could do a major rehabilitation to what's here, or we could just continue to operate it as it is now. So we're looking at a major expenditure, looking at what to do with this lock and dam structure here. And we're looking at 3 different decisions. So let's see what that might look like as a model. So we come on over here, and I have the 3 decisions: construct a new chamber, major rehabilitation of the existing chamber, or continue operation and maintenance as usual. Now we have 3 different states of the world here. One is, suppose in the future there is increased tonnage, or suppose tonnage stays stable, no change from what it is today, or tonnage could actually decrease. Okay, so we have 3 different states of the world. This is one of the ways that we can identify uncertainty. Now, if we wanted to, when we look at these values, we could use distributions here, but we're just trying to learn how to build a decision tree, so we're going to keep it simple. And what we have here is a cell that is in a row and in a column. So if we construct a new chamber and tonnage increases, we will have a change in benefits of $600 million. Let's try this cell here. If we have a major rehabilitation of the existing chamber, but tonnage is stable, then over the future we will lose $50 million in benefits. If we continue operation and maintenance as usual and there's decreased tonnage, we would gain $100 million in benefits. The numbers are entirely made up. Okay? Now down here we reflect the fact that we don't know what the likelihood of these different futures would be. So there's a 25% chance of increased tonnage, a 35% chance of stable tonnage, and a 40% chance of decreased tonnage. If you wanted to reflect uncertainty about these values, you would be free to replace these values with distributions. But as I said, we want to keep it simple. So you've worked a little bit with precision tree, so I'm going to work with a completed tree here. I started off, I created a new model, I called it chamber management, and my first node was a decision decision node. I had trouble saying that, didn't I? With 3 options coming off of it: construction, new, major rehabilitation, and normal operation and maintenance. And from each of these decision options, we had 3 possible states of the world: increased tonnage, stable tonnage, or decreased tonnage. Then what we do is we take our data from this table and we put it into our decision tree here. So the 25% increase you'll see is consistent throughout the tree. The 35%, the 35% probability of stable tonnage is consistent throughout the tree. And likewise the 40% possibility of a decrease in tonnage. Next, we have to put the payoffs. The payoffs go underneath the nodes. So if there is an increase in tonnage, that's this column, and there is a new chamber, that's this row, there would be $600 million. So that's where we put the payoff. So the payoffs go under this line. Okay? Now in a decision tree, what happens is the model is back solving itself. So what we get is this value right here, this 35, it's basically 25% of $600. That would be 150. So if you want to jot that down, it's plus 150. 35% of minus 100 is minus 35. So 150 minus 35 brings us down to 115. 40% chance of minus 200. 0.4 times minus 200 is minus 80. And 115 minus 80 gives me 35. So this number is the expected value of this node. This number is the expected value of this node. And this number is the expected value of this node. Now when I set up this model, I set it up as a simple optimization that was maximizing the outcome. So you will see here with this simple model, I only have two sets of nodes here, one decision node, one chance node, but this model could be as complex as you wanted with multiple chance nodes moving to the right and even other decision nodes. But this model is basically saying that if your goal is to maximize the expected value, then notice true is written here. This is saying this is the path that you want to take. So if you're working on a model that has some decision making in it, this is what you're going to want to do.